you about the board. Are we on?
We are on. We're always on.
G'day, Ben.
Hey, Richard.
Welcome to the garage.
Oh, thanks.
Last video we had the motor running. Awesome day.
Wonderful.
Huge step forward.
Yeah.
So all that's left now is a bit of a track day to tune it all. Brings us to the next step, which is
the point of everything, right? It's the spark that started it all.
I know what that is because I'm an electrician. It's the electrical thingamajig.
It is, yeah.
So we actually need we need a box for this. You know how we had a box for the bike? What do you got one for this as well?
A box of bits. I did see one.
Did you? Was it delivered today?
Just over here. Yeah,
why don't you bring it in and we'll have a look what's in it.
What have we got? Oh,
okay.
This.
I like what I think I see one here. Let me just get this stuff out of the way.
All right. So
in there,
it all starts with a turbocharger, right?
That doesn't look like any turbocharger I've ever seen, but this is a project like I've never seen.
That's right.
So
yeah, I'm pretty sure the air comes out of this one.
Oh, is that what it is?
Yeah.
I've had it all wrong for ages. So what's that funny little skinny little thing here? So we've got to talk a bit about what's going on here.
Right. So this is the center of our turbocharger. So we've machined off the turbine off the end of this shaft.
Beautiful.
So we've taken that down so that we've got a shaft that we can attach to.
Okay.
On the flip side is our compressor wheel.
Right, I get that. Yep.
So not attached yet.
And that would ultimately end up going in here like that.
Correct.
Right, with our compressor wheel in it.
Absolutely.
Got it. That's the business end of it.
Yep.
Right, yeah. Now the other end of it.
So the other end is our drive end.
Okay.
So obviously removing the turbine.
Yep.
We're adding a different drive mechanism, which is our BLDC motor.
Yep. Beautiful.
Done some design work.
Yep.
Over the last few weeks, and we've had some parts machined up.
Right. What's this?
So this is our adapter. This is the adapter that holds the motor, the BLDC motor, to the turbocharger.
Oh. So it sits on there.
Fits over there, and wouldn't you believe, got it perfect the first time, didn't we?
Well, I put it down. You've got to be lucky sometimes.
You do. It's I'm just
Perfect.
Really stoked.
So how does that actually hold on there? That's what else is in here? So that I can see here is a V-band.
Yep.
Does that V-band then clamps around that, does it?
It does, yeah. So this is the original V-band off the turbo.
Okay, so should we put it on and see how it looks? All right, so we do that, put that onto there. If my fingers can thread that on, okay.
Upside down and back to the front.
Yep, that's the way to do it. We always do stuff like that first. So that's that part.
Very good. So yeah, so this aluminium adapter will now hold our
DC motor.
DC motor.
Beautiful.
Absolute beast.
Yeah. Okay. So we'll take these screws out. We're gonna try and fit it.
We might pull this apart. We'll maybe pause the video. You do that. I'll do this. We can do it. Here we go.
Okay.
Okay.
So that's it.
That's the adapter on the motor.
Lovely.
Yep. So connecting this to our turbine shaft.
Yep.
Is a little collet. So on this shaft and the turbine shaft, we've machined a little flat, and this has the corresponding flat, and this will slip over the top, and it'll combine the two. So this is more or less just going to be able to float and sit between the two.
Beautiful. So it's not locking any shafts in anywhere.
No.
And the turbo, of course, the turbo is a journal type bearing, which does need to float a tiny little bit.
Yep.
And that'll allow us a little bit of movement there.
Absolutely.
Oh, very nice.
Yeah.
I like that.
Yeah. So we've got a little bit more machining left to do on this, just to get it exactly right.
Yep.
So we get a little bit of float but we don't fail on anything.
Oh, nice.
So we can't fit this just yet. But yeah, basically back to our. Not going to lose that, are we, Nat?
No.
There we go. And yeah, that's how they'll live together happily.
Yeah, with a V-band around that.
Yeah.
The rest of the turbo sits on that. The compressor wheel onto that. That in the bike, like that.
Like that.
I like it.
At 80,000 RPM.
Yep. What else would you want on your bike between the legs?
Oh, it's so good.
Cool.
Very
I like
cool.
It.
Yeah, very
nice,
cool.
very
So
nice.
that's a really exciting moment. So,
so the only thing that we actually still talked about, now this is my hat on, is we had problems with the Kelly controller.
Yes.
In that it needed to have some hall sensors on the motor, and it was still only limited to 45,000 RPM.
Yep.
Nowhere near where we wanted the turbo to spin.
No.
Because we're mapping this thing out so that it'll spin up to 90,000 RPM, creating a whole new map for the turbo, which we can then map the mass airflow to, and that gives us the environment that we give to the bike to work towards.
Yep.
All right. So on the end of that, we ditched the Kelly controller, and what did we buy?
We bought a Flip Sky. So mostly popular because of their ability to modify e-bikes and e-scooters.
Yeah.
And obviously hobbyist drone manufacturers and all sorts of things. But
sounds like us.
It sounds like us. So we've picked a model that has a max ERPM of 150,000.
Right.
Which matches well with our motor. So gives us plenty of headroom.
Yeah.
It's also sensorless, so it uses
like
back
us.
EMF.
Bit like us as well. The genre fits really well. Lovely. I love it so far.
Yeah.
Yeah. So it runs blind?
Runs blind. Yeah, it runs blind just on feel.
Yeah, lovely.
I think there's no one coming.
Yeah. So instead of a sensor, it works on picking up back EMFs as the magnets pass the coil. Electrically, it induces a small back EMF.
Yep.
It senses those tiny little peaks.
Yep.
And it uses those peaks to actually manage to spin it to a maximum potentially of 150 RPM. And because this motor is a two-pole motor, then it can spin up to 90,000 RPM. That's well within that 150 range.
Yep.
Beautiful. I love it. Yeah, nice,
really
nice.
So it's proven to be I haven't had a chance to test any of this yet, but we're very, very close. We'll hook these up and do some calibration tests.
Yeah,
and
bench
then,
testing.
Yeah, but all signs point to a fairly don't see any hurdles, fairly smooth run going through that motor testing. But once we've got that done, it's going to be a simulated. I guess it'll be a motor test with the compressor on the turbo, and we'll be able to map the turbo using the mass airflow meter,
which we've calibrated against the displacement of the 390. So we know the outputs of that for that displacement. What we're going to do is extrapolate that out to what the turbo is capable of doing. So we know where the surge line is and the choke line is,
and we know how to drive. We know how much mass airflow we can deliver at what RPM, so we can tune it.
Our tuning strategy, which we talked about.
Right.
Oh man, this is all coming together really, really nicely.
Yeah, so we've got an engine running well.
Yep. We've got a plan for the turbo.
Turbo's coming together.
A bench test bench testing that is by 60% ready to go.
Yep.
And that'll be exciting.
And a tuning strategy to pull it all together.
Yeah. All right. So testing
really cool.
Next video.
Yeah, will be, won't it? Yeah,
I think it might
testing
be.
the turbo.
Yeah.
Or at least testing the motor.
Test the motor first. Get that run up. Show that, which proves the controller works within the range we want before we put it on any load.
Yep.
And then hook the turbo onto our bench test with our data logging and our throttle position to start putting some load on the motor. Gather all that data.
Yep.
Produce a nice map.
Yep.
And there's the environment to work to.
Yeah.
Then it's all back to the bike.
Wow.
I love it.
Wow.
I love it.
Cool. All right.
That's it.
Sounds great. Looking forward to the next one.
Rightio.